Okay, so the third theme is the so-called socially aware interactive assistant, and so this is a result of a contribution of several people, also including the MetaNet Interactive Systems Vision Group, comprising Alex, Volker Steinmetz, Bernardo Magnini, so many people participated in that group, and also from the Meta Council. So what are socially aware interactive assistants, or SecondMe, as you say? Okay, they are multilingual assistants which support human interaction. So it comes from human-computer interaction in the past, let's say, to human, more generally speaking, human-artificial agent, including robot interaction, and even more generally, computer-mediated human interaction. So humans are communicating, and the computer can follow what is being said in this communication, and also they share data about this. So multilingual assistants are acting in various environments. They should be able to act in indoor environments, such as rooms or meeting rooms, in offices, apartments. They are also able to act in outdoor environments, such as say, smart city. So streets, cities, transportation, roads, and also in the virtual world, so in the web and on virtual and nowadays augmented worlds, including games and serious games. They can have a personalized interaction to users' needs and environment, and they are able to learn incrementally and individually from all sources and interactions. So what is the vision? The vision is that the socially aware interactive assistants can interact naturally with you wherever you are in any environment, interact naturally with your relatives wherever they are, interact in any language and in any communication modality, adapt and personalize to individual communication abilities, and this is especially the case for the handicapped people, but also to adapt with various environments, transcribe into text, fluent speech, and pronounce fluently any text. This is relationship between speech and text. Self-assess performances and recover from errors. Learn, personalize, and forget also through natural interaction. Act on objects in instrumented spaces, that is rooms, apartments, streets. Assist in language training and education in general. Provide a synthetic multimedia information analysis, what we could call knowledge. Recognize people identity, and also the gender, accent, language, but also style and even age. And if there are robots, move, manipulate objects, touch people, so gestural, tactile, and haptic interaction as well. Okay, so what is the idea? The idea is that in these interactions there are, let's say, global abilities, such as interact naturally with agents. And when I say agents, it comes from terminals, let's say iPhone, iPad, or smartphones, smartpad, to be too specific. Embodied conversational agents, robots, chatbots, human beings, things. If we look forward to the Internet of Things in the near future. And so this in various areas, in games, entertainment, education, communication, instrumented spaces, call centers, and so on and so forth. Able to communicate everywhere, and this includes also mobile applications and augmented reality in society, so in social networks and forums, also in multi-party communication, such as meetings, which includes several humans and several artificial agents or robots, and this in a personalized way, so taking care of the identity, the gender, the style, the age, the accent, and the language, to take also into account more linguistic-oriented aspects. This is global abilities, and then also domain-specific abilities. So those assistants should exhibit language proficiency. This is able to conduct speech-to-speech translation, interpretation in meetings or in video conferences, and also cross-lingual information access. Overcome handicap obstacles, and this deals with cross-modal or cross-media technologies, assistive applications, dealing also with sign language, not only speech and text, but also sign language, and kind of handicap, the ability to adapt to the communication environment. So in cars, you don't have the vision, and in meetings, you can speak loud to your assistant because you are participating in a meeting. I mentioned this reference to written support, so in terms of speech transcription, voice dictation, but also automatic subtitling of audiovisual data, and in the reverse reading machines. And provide personalized training for computer-aided language learning, including dialects. So this is for vitalization of languages, and more generally speaking of education, assessment of students, and self-assessment also of students. So now we work on the tentative roadmap. So first trying to figure out where we are, then trying to define the time to deliver, and when we say deliver, it means that we should reach for each of the applications good enough quality. When I say good enough quality, it means that we are able to assess the performances of the system, and at the same time we should be able to mention the performances that should be attained in order to make it usable and possible, so in both directions. So we look through the various aspects of the socially aware interactive assistance, global abilities and domain-specific abilities, so I say A to multilingualism, A to the authors, which relationship speech and text, A to the handicap, A to education and training, and very importantly also to the resource and evaluation dimension. So where are we first? Where are we? So what are the performances offered by the technologies nowadays? And what are the performances needed by the application? How do they meet? So if we look at automatic speech recognition, we know from the NIST evaluation, which were mentioned this morning by Thibaut Kleiner, that in terms of voice command and voice dictation, systems achieve performances which are close to humans, 2 to 4% word error rate. If we look now at radio and TV broadcast transcription, video transcription, we are still in the 10% word error rate level, which is not perfect, not as good as human, but it's sufficient for what we plan to do, which is automatic indexing of news or of video. And then if we go to conversational speech over the telephone and to meeting transcription performances, then it's not sufficient. We are still in the 50% word error rate. So 1 word upon 2 is misrecognized. And this is not sufficient to have a decent and usable application. And so especially for languages other than American English. If we now look to the machine translation, and we go now to Europe, and so Eurometrics give a very nice view on the situation for the 500 European language pairs. So here we see that machine translation achieves performances which are getting close to human translation for few European Union language pairs. And very interestingly, the best for the time being is Maltese to English, where the machine achieves 70% blur score compared with the human 80% blur score that we could think of. Okay, but it's far behind for most European Union language pairs, and this is for text translation and not for speech translation, which is even more difficult. Okay, now if we look at the competition, so a new program in the States, the Babel program, 2012 starting now to 2016, funded by the Intelligence Advanced Research Project Agency. And here the target is to conduct recognition for other languages than American English. And they look at more than 20 languages in very different language families all over the world. And also they look at what they call surprise languages, so 4 surprise languages. And the goal here is to be able at finals, this is in 2016, to develop an automatic speech recognition system for a new language within a week. Okay, this is a target. And then if we look at the commercial area, so we see with Apple Siri, which is presented as an intelligent personal assistant and knowledge navigator. So initially this was in fall 2011 when it was put on the market. It addresses 4 languages with 6 varieties. English was British English, US English, and Australian English. And now they go in the next generation to 9 languages and 20 varieties. And what is interesting is that they are not looking in terms of languages, but in terms of countries. So they embed in the language also the cultural dimension of the country. Okay, so we started this roadmap exercise. So here you see very graphically and generally speaking this priority on interacting naturally with agents in various environments and various applications. In the first phase, we see what is presently going on in this communication between human with his own reference and the agent with his own reference, and the interface is in terms of question and answer or a command and action, so it's rather simple. Next, we go to a real dialogue between human and agents, and this means a common reference. And next, to multi-party interactions and dialogue, including several interactions between humans, between agents, and sharing a common reference. Okay, so this is the same, but in terms of words. And so we see that we go from limited understanding and dialogue capabilities to a real usable dialogue interface, including emotions, recognition and production, and also context-aware dialogue using different sensors, also visual sensors, RFID and GPS. And next to multi-party human-agents interface, and here we have to deal with multiple voice synthesis, the ability to mimic one voice, and advanced understanding and advanced personalized dialogue, and we go back to indirect speech acts and also including prosodics in order to address lies or humor, for example. Okay, then some more excerpts about this roadmap. So
I'm afraid time is over, so if you could just wrap up.
Okay, so on modalities, on consciousness of performing capabilities, this dimension of exhibiting multilingual proficiency from multilingual to cross-lingual or flexilingual, and the area of resources which goes with it, so data on one side and evaluation, very importantly, on the other side. Thank you.